You're listening to Manx Radio, and I'm Judith Lay, welcoming you to the podcast of the Manx Sky at Night with Howard Parkin.
Twinkle, twinkle, little star, how I wonder what you are.
We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
And that familiar music tells us that once again it is time to welcome into the studio Howard Parkin for the October edition of the Manx Sky at Night. Faster my Howard.
Faster my Judith, it's great to be here again.
Well, the weeks fly by.
Don't they just?
And probably so do the planets. So
Yes, to an extent.
Well, we have had some glorious nights,
haven't we just? Been marvellous. And what we've got at the moment is the very, very bright and easy to spot Jupiter in the evening sky. And if you then get up about 6, 7 o'clock in the morning, in exactly the same place, you've got Venus. So we've got Jupiter in the evening and Venus in the morning. And each of them are competing with each other for brightness. Venus wins every time. But it's quite amazing. The amount of people have said to me, saw that bright star last night about 10 o'clock. It was still there at 7 o'clock. I says, no, the sky has turned completely by then. You're now looking at Venus.
That's right. Now, before we go any further, this weekend has been a significant one for stargazing.
Well, yes, we had the open night at the observatory. One of these open nights we do. We have tickets for Eventbrite, and we had that on Friday night, which was a great success. We had 40 people there. The weather was a bit iffy. We didn't really see much because it wasn't that good. A few people got a glimpse of the moon, but that was through the clouds, which wasn't particularly brilliant. But then on Saturday night, of course, we had the a partial eclipse of the moon around 9 o'clock at night, which was great. And although the weather wasn't brilliant, there was a bit of cloud around, there were a few people reported seeing it. And what happened is, for those who didn't see it, the very bottom of the moon, the bottom quadrant, if you like, the 6 o'clock to 8 o'clock part of the moon, just that tiny bit of the bottom went into the Earth's shadow and noticeably darkened. I saw it myself. I was away in London at the time, and I saw it myself, and it was it wasn't impressive, but at least we knew what was happening, and at least it tells us everything's right. We've predicted everything, and we know what's going on. There will be a much better eclipse of the moon, not next year, but the year after, and no doubt we'll be talking about that near the time.
Indeed, as with all of these things, as you say, it has to be a certain amount of luck with the weather.
Indeed.
And also luck about where you happen to be.
Yes.
Well,
I was lucky. I was in a hotel and I had a 25% chance of getting a room facing the right direction. Unfortunately, I did. So we managed to see bits of it. Again, it was cloudy down there, but we did see bits of it. But it was nice. There was so much interest about it. I met somebody in Marks and Spencer's on Friday morning. They said, not looking good for the weather tomorrow night, is it, Howard? And I had to think for a minute. Oh, of course, the eclipse.
Well, you are synonymous with stargazing on the
I'm
island.
afraid
So
yeah.
That's hardly surprising.
Yeah.
But yeah, you're absolutely right. I mean, just before we started this programme, I showed you a supplement
indeed.
in my Sunday newspaper last weekend.
All about space liftoff, it's called. What on Earth magazine from the Daily Mail.
And the lovely thing about it is, I think it's a Britannica publication, the Encyclopedia people. But the lovely thing is, it's aimed at youngsters.
Good fun facts. 50 amazing facts. And there's some good, like, did you know a pepperoni pizza was delivered to the space station?
I didn't know that.
I think it was cold by the time we got there, but that's beside the point.
But it does, the thing that I like about it, it does show you in real terms how long it would take.
That's right.
In like human hours, as you might say, to get from one place to another. So it does
I picked that up,
put a bit of perspective on how far away
I
these...
think, and I'm going to rustle the paper to tell you, because I just looked at that as we were waiting to go on air, and it says, if you drive at 100 miles an hour constantly, how long will it take you to get to various places? And for instance, it'll take an hour to get to space. 100 miles, space is 100 miles up, 100 miles an hour. 6 months to get to the moon. 62 years to get to Mars. 700 years to get to Jupiter. 17,000 years to get to the edge of our solar system. And 45 million years to get to the nearest star, Proxima Centauri. I think you'd be out of petrol by then, don't you?
I think you'd need to make a few fuel stops along the way.
1 or 2.
But we can stand here on our wonderful island and in our dark skies, and we can see some of those things. We can see Jupiter.
We can see Jupiter. We can see the edge of the Milky Way, the solar system and so on.
But it is good to put it into that kind of
Put it into perspective.
Yeah.
The one thing I try to do, especially when I do talks at schools, is show people. There's a little video I've got called Let's Compare Sizes. And it actually shows you the size of Mercury. It starts off with Mercury, then the Moon, and then the Earth, and then Venus, and so on. Then you get to the Sun, which is dramatically more bigger than all the planets, or any of the planets. But then people think all the stars are the same size and shape. Shape, yeah, but size, there are some stars that are absolutely huge in size. And compared to our sun is a very small star. But it's a static star. If you've got one of these big, massive stars, their solar systems, their life cycle of those stars is much, much less than ours. So life is unlikely to evolve. Well, it won't evolve, almost certainly, around these big stars. You need a small, stable white dwarf star like we've got, the sun, which burns for about 20 billion years to allow life to have evolved as it has on our Earth.
And I think it is important to remember this when we hear these popular media stories about something's heading for Earth or something's going to be this big. And, and that
there's an asteroid heading towards us, going to come close to the Earth in 2031, something like that. But it's about 4 times the distance to the Moon. And that's at the worst scenario, it'll be that close. 4 times the distance from the Earth to the Moon. But again, it makes for media, it makes for headlines.
It does. And as long as it doesn't frighten people, if it gets people interested in what's going on
that's the clue.
In the solar system, that's great.
It's when you get things that obviously fear, as you use the word fear, it's absolutely right. You don't want to frighten people. You just want to make people aware of what's going on. And yes, we do need to be aware of our fragility, and we need to look after the planet and all the rest. But not to the point of obsession and indeed causing panic and fear.
Yeah. Right. Let's look at some more fascinating facts for this month, because we started off talking about Venus and Jupiter dominating. Funny that we should just have been mentioning how far away Jupiter is, but it's dominating now.
It's dominating our evening sky. It goes through what we call opposition on the 3rd, which is of course Friday, and on the 3rd, next Friday, it is at its position at midnight, directly opposite where the sun is, hence the term opposition. It was actually at its nearest to us a couple of days earlier. I think tomorrow, it's at its nearest to us by a few million miles, depending on the orbit of the Earth, the orbit of Jupiter, affects its actual maximum distance towards us. And so that's interesting to look for. But as I say, if you want to see Jupiter for yourself, just go outside and have a look at the sky around 9 o'clock at night onwards. And of course, the hour's gone back now. Find Jupiter for yourself, because it dominates the eastern sky. Very, very bright, very easy to spot. And if you've got a pair of binoculars, look through those binoculars and you'll see up to four little tiny stars next to it, which stay with it all the time. They swap positions, they go from one side to the other. These are, of course, the Galilean moons discovered by Galileo in 1610, when he realised that Jupiter had moons. Maybe just as Jupiter's got moons, the sun has got planets. And this has led to the whole story about how we realise the sun is not orbiting the Earth, but in fact the other way around, the Earth orbits the sun. 1610. Incredible. 400 odd years ago.
Indeed. And still things to discover, things to understand.
Oh, very much so. Well, we just discovered only a few weeks ago now, they've said to they were analysing some rocks brought back from the Apollo missions back in the 70s, and they've discovered that the moon is not 4.6 billion years old, it's 4.8 billion years old. And you think, oh, so what? 2.2 of a billion? I may be wrong with my figures here, but it actually works out as 40 million years older than they thought it was. I mean, that's an easy mistake to make, I'm sure. But they found, obviously analysing these rocks, they were able to date them, and they found that these rocks were actually older than the other ones.
But it's not error. It's because they've got more sophisticated techniques for analysing what the data they have.
And we're always finding out different facts. And the whole point of science, and I talk about this quite often, the whole point of science is you come up with a theory, and then everybody will try and discredit that theory and prove your theory is incorrect. It's where the difference between a hypothesis and a theory, I think, is the wording. A hypothesis is something that is yet to be proven, and it only gets proven if lots of your peers and your people in the same profession say, well, okay, yeah, that's right. The Big Bang is a classic example, first put about by Hubble in 1922. Other scientists ridiculed it. Fred Hoyle, in particular, British astronomer, really ridiculed it. So much so that he he lost a lot of credibility because then they proved something else that proved the Big Bang Theory was probably right. Even now we're not 100%, but it fits the facts at the moment. And that's what you do with science. You get something to fit the facts and then everyone tries to knock it down.
But because it's science, it has to evolve.
Of course it does. It has to evolve repeatedly.
What are we going to evolve into next?
Well,
Saturn.
one thing I've forgotten, before we finish on Venus, I should just tell you, and I'm always very cautious of asking people to use binoculars and telescopes in daylight, because the sun, obviously, if you get anywhere near the sun, you're going to blind yourself. Please never, ever, ever look anywhere near the sun with a telescope or binoculars. But on the morning of the 9th of November, at 9:45 in the morning, the moon is going to glide over Venus. Now, Venus is bright enough to be seen in daylight, and if you look for Venus about 7 o'clock in the morning and see where it is, keep your eye on it, and even as the sky lightens, and when the sun comes up, Venus is far enough away from the sun you don't have to worry, but please be careful, as I said. And the moon, of course, will be visible in daylight, which always fascinates people. Kids always say, how come the moon's visible in daylight? And it's all to do with the orbit. But the moon, at 9:45, will glide over Venus. Venus will disappear behind the bright limb of the moon. Even though it's like daylight, you'll see it disappear if you use binoculars. And most exciting is it'll reappear about an hour later, but it will re-emerge from the other side of the moon where it's actually in darkness. So Venus will literally just blink back into existence. So well worth looking for. If the sky is clear on the morning of the 9th, it's well worth looking for.
Do you know, this is something that I've thought a few times when we've been chatting. When you mention binoculars, I always think of things like bird watching.
Absolutely.
I have never, until we started chatting and doing these programmes, I've never thought of them as an accessory for looking at the sky.
They're brilliant. I swear by them, because I've got binoculars, small bird binoculars I take away with me when I go. I've got a bigger pair at home, and I've got a telescope and all the rest. But binoculars are so portable and so handy, and you can use them for anything. And unlike telescopes, and this is something that most people don't realise, astronomical telescopes, the image is inverted. It's upside down. Doesn't matter when you're looking at Jupiter or the moon or the planets or nebulas or whatever, but if you're looking at a tree in the distance on a mountaintop or at the side of a mountain, it'll look odd to be upside down. The reason we do that, because every time you pass light through a different lens, it degrades. You lose a bit of quality. So the less lenses you use, the better it is. So with telescopes, we have them upside down, but binoculars always have them the right way up because they have the extra lenses in. But they're portable, and you can take them anywhere. The Pleiades, not far from Jupiter, back to Jupiter, not far from Jupiter, just to the left of Jupiter, is the wonderful star cluster called the Pleiades. And that, through a pair of binoculars, is stunning. Through a telescope, it's quite good, but binoculars give you the full field of view of the whole thing, and it's really worth looking for. Just to the left of Jupiter at the moment.
But just remind us of the rule, never to use
anywhere near the sun. Never go near the sun, because what you're doing, you're not just magnifying the light of the sun, which is bright anyway, but you're also magnifying the heat that's coming through as well. And I'm sure as kids, they've all done the thing with a magnifying glass and burnt the back of your hand. Imagine doing that to your eyeball. As Patrick Moore used to say, with your eyesight, never look at the sun with a telescope. You've got two chances, left eye and right eye. And that is very true. And you must never go anywhere near it. So I'm always very wary. Eclipses is always a problem, because we encourage people to use telescopes and all sorts of things to look at eclipses, but they've got to be properly adapted with filters or with projection methods. Or best way to watch any of these things is on the TV, watching it live and with professional equipment being used by professional astronomers somewhere in the world.
Indeed. Thank you very much for that, Howard. So, Pleiades...
Mentioned the Pleiades already.
Yeah.
Wonderful to look at. Very easy to spot, because you've got the... Jupiter literally is a signpost to the right of them. So just scan with your binoculars, look for the moons of Jupiter, then just go to the left slightly and up a bit, and you'll see this wonderful patch of sky, which is the Pleiades star cluster. The seven sisters it represents, the seven sisters who were weeping because one of them got lost. I think we might have done this story before. And it's in what we call the watery part of the sky. And that's because the stars become visible when the Nile flooded. And sometimes this folklore and mythology, which is great fun and great laugh sometimes, there's a germ of truth in it. So that's the Pleiades to find. And the other thing I must mention, of course, is the Leonid meteor shower. Every year around the 16th, 17th of November, we have a meteor shower called the Leonids. They come from the direction of the constellation Leo, which incidentally is the other side of the main winter constellations we'll be talking about next month. So it comes up a bit later in the sky, so it's about 1, 2 o'clock in the morning where the constellation clears the horizon. But the shower comes out of Leo on the 16th, 17th of November, and it's well worth looking for, because The Leonids sometimes can be quite dramatic. But usually there's only about 10 an hour, something like that. But always well worth looking for.
Right. Now, you promised me a ghost story.
I have indeed. I've got a wonderful ghost story, and it comes up every year, this story. And we may have done it before, but it's too good a story not to ignore. Every year, we have the beautiful Manx sunny weather in June and July. And of course, the sun is up till about 11 o'clock at night, and the sun shines benevolently on us, and we all go to Peel and have an ice cream and walk along the prom at 10 o'clock at night, and you still say, oh, look, it's still light. But the sun occupies a point in the sky. So if you were to go to Peel, we'll say the 21st of June, for example, and you looked out to where the sun is, we'll say 9 o'clock at night, the sun will be in a particular position. If someone wants to try this out for me, please do. Invite me to Peel. I'll buy you an ice cream if you do. And we'll stand on the prom and we'll look where the sun is, and we'll line it up with a telegraph pole or a Peel castle or whatever. Then what you do, you come back on Halloween. Actually, it's the 29th of October to be absolutely precise, which is tonight. You line up the same part of the sky at 9 o'clock at night, and you'll see a star there. This is the star Arcturus. And the star Arcturus is the one, hopefully most of our listeners are very knowledgeable now. They all know where the plough is. Find the plough, which is sitting on the northern horizon. Follow the bend of the handle of the plough down. You'll come to a star sitting on the northwestern horizon. That's the star Arcturus. Arcturus is occupying in late October the exact same position the sun was occupying in late June. It's known as the ghost of the summer sun.
That's very romantic,
well,
isn't
it's not bad, is it?
Very lovely. The ghost of the summer sun.
Arcturus, which was famously used to illuminate a exhibition, the Great Expo they had in Chicago in 1930, and they decided to light the exhibition, like Blackpool Lights, but in Chicago. They decided to use the light from Arcturus to light it because they had an exhibition in New York 30 years earlier. I think it may be New York, maybe somewhere else. 40 years earlier. So they decided, I know what we'll do. We'll use the light of a star that is that far away to light up our expo. And they did. And it was a success and all the rest. But we now know that Arcturus isn't 40 light years away. It's 36 light years away. So they get it wrong. But it's two little stories about Arcturus, and Arcturus is incidentally one of the brightest stars in the sky, from our perspective, from the Isle of Man in particular. So well worth looking for. Follow the handle of the plough down and you'll come to a bright star, and that's the star Arcturus, the ghost of the summer sun.
yourself.
This place is coming like a ghost town.
No job to be found in this country.
Can't go on no more. The people getting hungry.
You're listening to the October edition of the Manx Sky at Night. Howard Parkin here in the studio. Great music choice from the specials.
Absolutely.
Ghost Town. Now, kind of keeping in the same sort of area, alien life. You reckon that alien life is now inevitable?
That's what the scientists are saying. There was a report in the Nature magazine a few weeks ago now saying that the probability of finding life, even in our solar system, now has, according to this particular scientist whose name escapes me, is almost inevitable. We've launched a spacecraft, the Europeans launched a spacecraft to Jupiter a few months ago now in May, and NASA are getting ready to launch their spacecraft to Jupiter next year, the Europa Clipper. And the whole point of both these missions, they're looking at what they call the icy moons of Jupiter. Incidentally, the first spacecraft launched is called JUICE. They have these wonderful acronyms. JUICE stands for Jupiter Icy Moons Explorer. I don't know where the M comes in, but never mind. But that's what it's called, JUICE. And what they're looking for is for life to exist as we understand it, you've got to have water, liquid water that stays liquid all the time. If it freezes, it expands and it destroys cells. Therefore, life can't exist if water freezes regularly. But if you've got water permanently somewhere, even if it freezes and then unfreezes, at the bottom of the lake you've still got water, or the bottom of the ocean you've still got liquid water, and life can move into that when the temperature drops. And that's the theory. And we believe there's definitely, well, I say definitely, there's 99% probability that the moons Enceladus around Saturn and Europa on Jupiter, around Jupiter, are ice-covered moons with ice on their surface, completely covered in ice. But the residual heat from their formation has left a heat source in the middle of the core of these moons, and this provides enough heat to keep some of the ice as a liquid. And therefore, one of the main parameters for life to exist, liquid water all the year round, or all the period that moon is going around Jupiter and Jupiter goes around the sun, is going to give the probability of life. We've discovered carbonate compounds and things like that, which are the molecules of life. And what they're saying, all the parameters are, all the exploration we're doing, all the samples we're bringing back, all the spectroscopic analysis, and all these different experiments are proving, or not proving, that's the wrong word, but are indicating that the inevitability that life will exist somewhere else in our universe. Now, we're not talking about little green men, sorry, we're not talking about civilizations, we're not talking about communicative aliens or whatever. We're talking about primitive amoeba, bacteria, or something that is just basically the fundaments of life. Whether that evolves then to become sentient beings like we are, that is another story, and that is a totally different concept. But the discovery of life, the ability for life to exist on other planets, is a huge goal for the scientist. We are actively looking for it on Mars with the two rovers we've got currently wandering now Mars, Perseverance and Curiosity, and now we've got these two spacecraft, one of them on the way, one due to be on the way shortly. And this is when this report came out that said the likelihood of life existing elsewhere in our solar system, he actually said inevitable. I would have said is very high. He knows better than I. He's saying inevitable.
So Psyche launch, what's that all
Well,
about?
Psyche is a very exciting mission that was launched a few weeks ago. It's been launched to an asteroid called Psyche, that's hence the term. And what this Psyche is, this is a remnant, we believe, from the origins of the solar system. And it is thought to be very, very rich in metals and minerals, and it's thought to be the core or the ancient core of what would have formed. The way that they believe these things form is they form gravitationally. You get a heavy metal core in the middle and then the rocks and the other stuff on the outside. That's a very primitive way of describing it. But what they've worked out from spectroscopic analysis is Psyche is very heavy, rich in metals. And there's even been speculation that this asteroid could contain huge quantities of silver and vanadium and diamonds and gold and all this sort of stuff. And the value of it on current market terms is enormous. But that's not why we're going there. Again, we're going there to see if we can understand how the solar system evolved. If we can get there to this asteroid and look at it, and there's no reason why we shouldn't. It's going to take 9 years to get there. But as we've proved with other space missions now, once you launch them and get them into space, get them on the way, nothing's going to go wrong. There's no storms or rust or anything else to detract from it. The only thing that would go wrong with it if you send it a wrong signal, and that's happened before now. But Psyche is a very exciting mission, and when it gets there in 9 years' time, they'll hopefully be getting all sorts of analysis. And there's even talk of mining the asteroids. And this isn't science fiction. This is a true fact. NASA are actively looking at the idea, and private companies are doing this in America as well. You go out to the asteroid belt, because these elements on the Earth that are very rare and very expensive, they may exist in profusion in the asteroid belt. So with the technology we've got, it wouldn't be impossible to go out to the asteroid belt and mine them, bring the minerals back to the Earth for us to use in our whatever we want to use them for. And that is on the drawing board as a possibility. As the cost of space travel comes down in real terms against the cost of extraction on the Earth goes up also in real terms, obviously, there'll come a time when extraction from the outer solar system or the solar system will be cheaper than mining on Earth. Which leads us beautifully onto our next tale, actually, the OSIRIS-REx mission. Because OSIRIS-REx was another mission that was planned many, many years ago, and they finally went to OSIRIS-REx, to Bennu, the asteroid Bennu, and they brought some samples back. And they're very, very excited about those. To go back to what we were talking about earlier, they've examined some. It's quite amusing, actually. Well, not for the scientist. They can't get in it. They've managed to work out what they've got in it. They've got some dust and material on the outside of the collection receptacle, but the tools they want to use to get into it don't work. It's got locked by for some reason, not by aliens, I hasten to add, using aliens again, but they can't get into it, so they're looking at how they're going to get in it without damaging the samples and all the rest. But what they've discovered from the little bits of rock that they've got on the outside is they've got carbonates, they've got carbonate rocks, and they've got carbon compounds, and they've got water ice. And they've got the basic ingredients for life existing on Bennu, which we've now brought back to Earth, which is why they're being so careful with the opening of it. And they're really excited about this because this is the first true quantity. Half a pound. Is it half a bit? A pound. I think they've got a pound of material. Doesn't sound a lot, but that's come from way, way out in space.
I think spookier than the ghost story is the fact that they can't open the box.
Can't open the box. Pandora's box. Don't go there.
Indeed. And we have been beaten by the clock, Howard.
Unfortunately, we have.
So we're going to have to press pause there, and we'll see you in 4 weeks' time.
In the end of November. I look forward to that. Thank you, Judith. Good night.